Assalamu alaikum, my dear students. Welcome to my class. Hope all of you are fine and staying safe by the grace of Almighty Allah. Today, I will start a new chapter from your chemistry book, and that is chapter 9, Acid-Base Balance. And from this chapter, today I will mainly discuss about acid. So let's start the class. Acid. Acid are those substances that releases hydrogen ions in water. That means acidic substance produces hydrogen ion or dissociates into hydrogen ion in water. So this is very clear. Acidic substance contains hydrogen atom in their molecules, and on the basis of degree of dissociation, that means on the basis of rate of production of hydrogen ion in water, acids are mainly two types. Number one, strong acids. Strong acids are those acids in which all the acid molecules become ions in water. That means strong acids are those acids which are completely dissociates and produces hydrogen ion in water. For example, hydrochloric acid, sulfuric acid, nitric acid, etc. And another type is weak acid. Weak acid are those substances in which only a few acid molecule becomes ions in water. That means weak acids are those which only a few molecules dissociates into hydrogen ions. For example, acetic acid, citric acid, carbonic acid. That means all organic acids are weak acids. Now follow some more examples of strong acids and weak acids. Hydrochloric acid, nitric acid, sulfuric acid, hydrobromic acid, hydroiodic acid, perchloric acid, chloric acid, all are the examples of strong acids. And oxalic acid, sulfurous acid, phosphoric acid, nitrous acid, benzoic acid, acetic acid, formic acid, carbonic acid, etc. all are the examples of weak acids. Now we will know about another type of acids. On the basis of the presence of amount of acid molecules in the same volume of water is two types: concentrated acid and diluted acids. Concentrated acid contains a large amount of pure acid dissolved in water, but diluted acids contain a small amount of acid in water. That means if two same volume water if you are taken, and between these two water if you mixed in one more amount of acid and another one small amount of acid, then more amount of acid containing solution is called concentrated acid solution, and the small amount or less amount acid containing solution will be called diluted acid solution. For example, 2 bottles of hydrochloric acid have concentration of 5 molar and 0.5 molar. You know that molarity is the unit of concentration. So which one will be concentrated acid? Obviously 5 molar acid, because 5 molar and 0.5 molar there are far difference in concentration. So I hope you understand which are actually concentrated and diluted acid. Now if you observe this picture, then it will be clear. Follow here, this is the diluted acid solution. Follow here, inside this acid solution the number of acid molecules are very small. These small balls are actually represents the water molecules, and these big balls are represents the acid molecules. So here only 3 acid molecules are present inside this water, but here in this picture follow here more acid molecules are present in the same volume of water. So must be this is an concentrated acid picture and this is diluted acid picture. Now follow this picture carefully, then it will be more clear to you about the concentrated and diluted weak and strong acids. Follow here, this is the concentrated weak acid solution. How? Follow this. Concentrated because here more amount of acid molecules are present. And why it is called weak acid? Because only one acid molecules are dissociates and produce hydrogen ion, and other all acid molecules are not dissociate, remain unchanged. In this picture, this is concentrated strong acid. Concentrated because here more amount of acid molecules are present. For this is known as concentrated, and all the acid molecules follow here, all the acid molecules are dissociated and produce hydrogen ion and anion. So this solution is known as concentrated strong acid solution. Here this is diluted weak acid because diluted because very less number of acid molecules are present. For this is called diluted, and only one acid molecules are dissociate and produce hydrogen ion. For this is diluted weak acid, and this is diluted strong acid. Why? Because presence of amount of acid is less here, but the all acid molecules are dissociates and produces hydrogen ion. For this they are diluted strong acid. So now it is very clear, strong acid means which are completely dissociates and produce hydrogen ion, and weak acid means which are dissociates in less amount, they are called weak acid. Concentrated means when the amount of acid molecule is more, then it is concentrated. When the amount of acid molecule is less, then it is called weak acids. Now I have shown here different acidic foods and their acids. Follow here, milk, curd. This type of food contains lactic acid. Lemon, orange type fruits contains citric acid. Apple contains malic acid. Tamarind, grapes contains tartaric acid. Soft drinks contains carbonic acid. Vinegar contains acetic acid, or it is also called ethanoic acid. Tea contains tannic acid. Amla, guava, these type of fruit contains ascorbic acid. And tomato, inside the tomato there is present oxalic acid. So you have to remember the name of the acids of these foods. Now you will know about properties of acids. Acids are generally liquids. They are solution of compounds in water. If concentrated, they can be corrosive. That means concentrated acids are corrosive to our skin or to metal, because if any metal you insert in the concentrated acid, then there will be a reaction and metal will corroded. Or if any one drop concentrated acids are falls on our skin, then there will be burn. So this is very corrosive substance. Acid tastes sour. We can easily understand this property because we know that all acidic foods are sour in taste. It turns blue litmus paper red. That means here litmus paper is actually an indicator. So this is the properties of acid which turns blue litmus paper into red. Usually react with metal to form salts. All acids react with metals and produce salt and hydrogen gas. Acid contains hydrogen ion. This is common properties, because without hydrogen ions acid cannot, any chemical substance cannot be hydrogen. But not always hydrogen containing substance will be acid. Only in that time that will be acid when it produces hydrogen ion in aqueous solution. For example, methane. Methane also compound of carbon and hydrogen, but methane is not acid. Why? Because it cannot produce hydrogen ion in aqueous solution. Another example is ammonia. It also a hydrogen compound, but this is not acid because it cannot produce hydrogen ion in aqueous solution. So hydrogen ion containing substance only in that time will be called acid when it produces hydrogen ion in aqueous solution. Another point follow here, turn universal indicator from green to red. This is also an indicator, and acid always turn its green to red, and the pH value of acid is always less than 7. So these are the actually common properties of acids. Now follow another slide where you will get more points. For example, acid turns methyl orange to red. Methyl orange also is the another indicator. And acid also neutralizes base. That means acid reacts with base and produce salt and water. Base actually metallic hydroxides or oxides. So acid also reacts with metallic oxides or hydroxide compounds and produce salt and water. And acids are also react with carbonate or bicarbonate compounds to produce salt, water and carbon dioxide gas. We will know about this reaction. So these are also properties of acid. Follow another slide. Also you get another point from this slide. Acids are electrolytes. Electrolytes means, you know that electrolytes are those solutions which conduct electricity or which is actually allowed to pass electricity. So acid solution is also used as electrolytes. So these are the actually properties of acid. You can make note from these 3 slides on the properties of acid. Now I will discuss about the reaction of acid. Generally these 4 types reaction occur in acid. That means acid reacts with metal or metal oxide or metal hydroxide and metal carbonate compound. At first, reaction of metal with acid. Follow here, acid always reacts with any metal and produce what? Metallic salt and hydrogen gas. For example, when magnesium reacts with hydrochloric acid, there is produced magnesium chloride hydrogen gas. If there is aluminum, then there will produce aluminum trichloride and hydrogen gas, like this way. Now, reaction of acids and metals, more examples follow here. If you use calcium and hydrochloric acid, then there is also produce hydrogen gas and calcium chloride. If you use here nitric acid, then calcium nitrate and hydrogen gas. If you use sulfuric acid, then also there is produced calcium sulfate and hydrogen gas, like this way. And if you use zinc with hydrochloric acid, there will be produced zinc chloride. So actually these are the more examples of reaction between acid and metal. Now follow reactions between acid and metallic oxides. Follow here, when metallic oxide reacts with acid, then there is produced salt and water. Metallic oxides such as copper oxide, when reacts with hydrochloric acid, produce copper chloride plus water. Sodium oxide reacts with hydrochloric acid, produce sodium chloride, water. Copper oxide, when reacts with sulfuric acid, produce copper sulfate, water. Like this way, these are the example equation of reaction between metal oxides and acids. Now reaction of acids and bases. Bases means metal hydroxides. Follow here, when acid reacts with metal hydroxide, then there is produced salt and water. For example, hydrochloric acid when reacts with sodium hydroxide, there is produced sodium chloride water. When acetic acid reacts with sodium hydroxide, then there is produced sodium acetate plus water. When sulfuric acid reacts with potassium hydroxide, produce potassium sulfate and water. Like this way, when any acid reacts with any base, there is must be produced salt and water. Now, follow when acid reacts with metal carbonate or metal hydrogen carbonate, then there is produced salt, carbon dioxide and water. For example, when sodium carbonate reacts with hydrochloric acid, produce sodium chloride, water and carbon dioxide. When sodium bicarbonate reacts with hydrochloric acid, produce sodium chloride, water and carbon dioxide. Like this way, when zinc carbonate reacts with hydrochloric acid, produce zinc chloride, water, carbon dioxide, etc. So follow here, in each reaction always there is produced water and carbon dioxide gas. Now you can test this carbon dioxide gas by a specific test, by a specific experiment, and that means you have to identify the produced gas is carbon dioxide or another gas. So how will you identify the carbon dioxide gas? By doing an experiment, easily we can test carbon dioxide gas, and the name of this experiment is lime water test. Lime water test of carbon dioxide gas. Carbon dioxide gas when passed through the lime water, then the clear lime water turns milky. Actually, lime water is a calcium hydroxide, because lime is calcium oxide. When it dissolves in water, then there is produced calcium hydroxide. So lime water is actually calcium hydroxide, and it is clear solution because calcium oxide is a water soluble substance. For this, lime water is a clear solution. But when carbon dioxide gas is passed through lime water, then it turns milky. Milky means it turns turbid, or the solution become opaque. Why? Because carbon dioxide gas reacts with calcium hydroxide and produce calcium carbonate and water, and this calcium carbonate compound is actually insoluble in water. For this, the clear solution gradually turns into cloudy, milky or turbid by this following equation. Follow here, clear lime water how turns milky through the passing carbon dioxide gas. Actually, at first, if the question may come like this way, how will you identify carbon dioxide gas, or explain the lime water test of carbon dioxide gas, or what will happen if carbon dioxide gas is passed through lime water, then in this type of question answers you can write like this way. So here is an interesting matter is that when carbon dioxide gas is passed through lime water, then it becomes turbid due to the production of calcium carbonate, because calcium carbonate is insoluble in water. But if you pass more carbon dioxide gas, then it becomes again clear. Why? Because when you pass more carbon dioxide gas, then calcium carbonate water again reacts with carbon dioxide gas and produce calcium bicarbonate substance, and this calcium bicarbonate substance actually water soluble. For this, the solution becomes clear again. So like this way we can confirm the produced gas is carbon dioxide gas. Now I will discuss about the role of water in acidity. That means why always acid is in water. Actually, without water, acid cannot show any properties of acidity, because when acids are soluble in water or dissolved in water, then they produce hydrogen ion, isn't it? And these hydrogen ion actually are responsible for the acidic properties. For this, the role of water in acidity is great, or is most. Without water, acid cannot show any acidic properties. Follow this picture. Here, this is the dry citric acid crystals. That means this is a dry acid. But in this dry acid, when we insert any blue litmus paper, follow here, it has no change. Or if we put any metal, such as there is magnesium metal, then also it there is not occurring any reaction. But when these crystals are dissolved in water and make solution, then blue litmus paper turns into red, and when insert metal, then it reacts. Follow here, there is creating bubbles. That means here magnesium reacts with acid and produces hydrogen gas. These bubbles are actually for hydrogen gas. So from this experiment, it is very clear is that without solution or without water, acid cannot show its any properties, physical or chemical. So this is the actually role of water in acidity. Now I will discuss about preparation of some acids. At first, hydrochloric acid. Hydrochloric acid actually prepared by dissolving hydrogen chloride gas in water. That means when hydrogen chloride gas is dissolved in water, then that solution is known as hydrochloric acid. Now, preparation of nitric acid solution. Nitric acid solution actually prepared at first ammonia and oxygen reacts together and produce nitric oxide and water. Then this nitric oxide gas again oxidized or reacts with oxygen and produce nitrogen dioxide gas, and this nitrogen dioxide gas again absorbed by water in presence of oxygen and produce nitric acid solution. Like this way actually nitric acid is prepared in the laboratory, and nitric acid directly reacts with the sunlight. For this it is preserved in colored bottle, not white colored bottle, because white, if it kept in white colored bottle, then it directly reacts with sunlight and produces nitrogen dioxide, or it actually breaks down from the nitric acid and converted into nitrogen dioxide gas. For this it is always preserved in brown color bottle. Now there is preparation of sulfuric acid. Sulfuric acid generally manufactured by the contact process. How? At first sulfur and air together in a furnace reacts together and produce sulfur dioxide and oxygen. Then this sulfur dioxide gas again reacts with oxygen and produce sulfur trioxide gas. Then this sulfur trioxide gas again reacts with concentrated sulfuric acid and produce oleum. Oleum is actually fuming sulfuric acid, and in the finally this fuming sulfuric acid is mixed with water and produces sulfuric acid solution. Actually this is known as contact process, and you will know about this contact process in the 11th chapter in detail. So in this way actually sulfuric acid is manufactured in the industry or in laboratory. The equation of production of sulfuric acid: sulfur reacts with oxygen, produce sulfur dioxide, and sulfur dioxide reacts with oxygen, produce sulfur trioxide, and sulfur trioxide reacts with water and produce sulfuric acid. But this is not actually done in laboratory, because this is highly exothermic reaction, and for this actually sulfur trioxide is absorbed by the sulfuric acid, and there is produced oleum, and finally this oleum is diluted with water, and there is produced the sulfuric acid solution. In this process is followed in the industry or laboratory to produce sulfuric acid. So my dear students, I hope you clearly understand about the acid. So today you will know many things about acid: definition, its characteristics you have to remember, and also its different reactions and different type of acid containing foods you have to remember, and also about the preparation of some different acids. So today up to this, you will take the preparation on acid properly following your book, and in next class I will come back with the discussion of base. Up to that, best of luck, be safe, be well, goodbye.